One disadvantage of FCFS is there is something called as convoy effect. Convoy, you know that, right? When when a VIP is going, along with him 20-30 cars will be going with him, right? And what happens? So the time for which he is passing through some junction, for the entire time everyone else will be blocked. That is called as convoy effect, right? Now this convoy effect is severe in this FCFS, in the sense when a process is having a heavy burst time, then all the processes which are after it are going to starve. That is also called as starvation or convoy effect. Now let's see how it is possible here. I'll take the two cases to just study them, to study the effect. It will give you a clear understanding. See, I have three processes and the arrival times are 0, 1, 1 and then 20, 2 and 1 are the burst times, right? So let me schedule them first. Now I am assuming that I am going to start the scheduling at time 0. Which one is the first one that arrived? The first one that arrived is P1 at time 0. Therefore, I have to schedule P1. And what is the time for this? The burst time is 20. So it takes 20 units of time to finish P1 if I start from 0, right? And after that, what is that I could schedule? I could schedule, see, P2 and P3 are having same arrival times, and I told you that the one with the lower process ID is going to get the highest precedence, right? But then there is no relation between convoy effect and then process arriving at the same time. Here it so happened that the process are arriving at same time, but it doesn't have anything to do with the convoy effect. Convoy effect is independent of that, right? Now, so we see that P2 and P3 are arriving at the same time. Therefore, which one should you schedule first? The P2, right? So I am going to schedule P2 first. Fine. And what is the burst time? The burst time for P2 is 2 units. Therefore, the total time is 22. Got it? And then P3 will be scheduled. And what is the burst time for P3? It is 1 unit. Therefore, it is 23. So one thing you should observe is the total schedule, if it is going to start at 0, by the time the schedule ends, this is the schedule begin start time and this is the schedule end time, right? So by the time this total schedule, you can add all this and that should be equal to that, in case if it is starting with 0 and in case if there are no gaps. In case if there are gaps in the middle, it does not hold. Anyway, in this case, the schedule is taking a total time of 23 and even the burst time sum is 23. It happened here because there are no gaps here, which means CPU need not wait for any process, because all the processes are available. By the end of one process, next one is available. By the end of second one, next one is available all the time. Now let's write everything. One is, what is completion time? So completion time for P1 is 20, P2 is 22, P3 is 23, right? Then what is turnaround time? So I told you that turnaround time is completion time minus arrival time. How much is it? 20 here, 21 here and 22 here, right? Isn't it? I'm just subtracting this one from this one, completion time minus arrival time. And after finding out this turnaround time, you could find out the waiting time. What is waiting time? Waiting time is turnaround time minus burst time. From this one you have to remove this, so which means 0 here and then 19 here and then 21 here, right? This is the waiting time. So how does this convoy effect is here is, if you find out the average waiting time of every process, average waiting time, you have to take all the waiting times and then you have to divide it with the number of processes, which is 0 plus 19 plus 21 by 3. This is the average waiting time. Now it is nothing but 40 divided by 3. This is the average waiting time for this example, for this schedule. Now let's do the same processes in a different order. If the arrival times are different in such a way that, see this here, what happened is the one with the largest burst time arrived first. That is why P1 got scheduled first. Now if the same three processes are arriving in such a way that the one with the largest burst time has arrived last, which means all the remaining processes have arrived early and this one arrived late. Now in this one, what happens is, I'm just drawing the schedule here. So what is the first one that has to be executed? The process with arrival time 0. So we have two choices, P2 and P3. Which one should I choose? Obviously P2, because the one with the lesser process ID is going to take the higher precedence, right? Now if it starts at 0, burst time is going to be 2. isn't it? Then what is the next one? I have only one choice, P3. What is the exit burst time? 1. Therefore, it is going to be 3. Understood this? Why P2 and P3 is both are having the least arrival time, and out of them P2 is having the least process ID. That is why P2 first and then P3 next. And obviously the last one is P1. Its arrival time is 1. That is why it is the last one, right? And then its burst time is 20. Therefore, it is going to be 23. Now the same thing, write the completion time and everything. So if I write the completion time, when it is going to complete, P1 is going to complete at 23, and P2 is going to complete at 2, and P3 is going to complete at 3. After that you have to write the turnaround time. So what is turnaround time? Turnaround time is completion time minus arrival time. How much is this? 22 here, 2 here and 3 here. And then what is the waiting time? Waiting time is turnaround time minus burst time, which means these two, right? Then what do we get? 22 minus 20 is 2 here, 0 here, and it is 2 here, right? Isn't it? The waiting time for P2 is 0 because it got scheduled immediately, and the waiting time for P3 is 2 because it arrived at 0 but it got scheduled at 2, and waiting for P3 is 2 because it arrived at 1 and it got scheduled at 3, right? Now in this case, what is the average waiting time? So if I write the average waiting time, so it is 4 by 3. 4 by 3 is the average waiting time, right? So here the average waiting time is 40 by 3. Here the average waiting time is 4 by 3, which means the processes are not waiting for a long time. So whenever you have a big process, the one with the burst time, very high burst time, whenever it arrives early in the initial phase, that is going to take a lot of time for it to finish, so that during that entire time all the other processes are going to stop. This is called convoy effect. This is the disadvantage of FCFS, and so we are going to solve this problem by scheduling the processes which are having lower burst times initially. That is nothing but shortest job first. We shall see it later.